Have you ever gazed up at the stars and wondered if there's life out there beyond our planet? Our universe is a vast, unending expanse, teeming with galaxies, each one home to billions of stars. Amongst this cosmic sea, could there be planets that harbour life, much like our own blue gem Earth? Scientific endeavours have long been aimed at unravelling this mystery. We've sent probes to Mars, analysed the gaseous composition of distant planets, and peered into the farthest corners of the cosmos. The Kepler mission, a jewel in the crown of space exploration, has discovered thousands of exoplanets, many of which lie in the Goldilocks zone, not too hot, not too cold, but just right for life as we know it. While we have yet to find concrete evidence of life beyond Earth, the search continues, fueled by the tantalizing possibilities. As we continue to explore the vastness of the universe, who knows what marvels we may stumble upon next? Life as we know it on Earth is a complex interplay of biology and chemistry. When we talk about life, we're essentially talking about three things: cells, DNA, and proteins. Cells are the basic units of life, like tiny factories where all the magic happens. DNA, or deoxyribonucleic acid if you're feeling fancy, is the blueprint for life. It's the instruction manual that tells cells what to do. And proteins? They're the workforce, the builders and doers that carry out these instructions. But life on Earth isn't just about these three. It's also about water and carbon. Water, that refreshing drink, is also the universal solvent in which all these biological processes take place. Carbon, on the other hand, is the ultimate building block, the Lego of life, if you will. It's versatile, able to bond with other elements in countless ways to form the complex molecules that make life possible. And yet, with these basic ingredients, life on Earth has managed to adapt to some of the most extreme conditions. From the crushing pressures of the deepest oceans, where sunlight never reaches, to the thin, cold air of the highest mountain peaks, life finds a way. Life on Earth is incredibly diverse, yet all life shares certain basic characteristics. But what if life on other planets doesn't play by the same rules? Imagine a world where life is not based on DNA, but some other form of genetic material. A world where the blueprint of life is not written in the language of nucleotides, but in an entirely different dialect. Let's dive into the theories of alternative biochemistry. Picture life built on silicon instead of carbon. Silicon, like carbon, can form 4 bonds, making it a plausible candidate for creating complex molecules. However, silicon-based life forms would likely require much higher temperatures to survive, painting a picture of a world far hotter than ours. Now, consider a life where the solvent of choice is not water but ammonia. Ammonia, under certain conditions, can dissolve a wide range of organic compounds, just like water, but unlike water, ammonia remains liquid at much lower temperatures. So imagine a world where life thrives in bone-chilling cold, a stark contrast to our warm, water-filled Earth. Such life forms, if they exist, might function and survive in environments vastly different from Earth. They could be inhaling sulfur instead of oxygen, or perhaps basking in the glow of radiation that would be lethal to us. The possibilities are endless and fascinating. Alien life might be so different from us that we might not even recognize it as life at first. But in the grand cosmic play, it's these differences that make the universe a stage of infinite possibilities. The search for extraterrestrial life is a journey into the unknown. We've journeyed through the possibilities, from the familiar to the utterly alien. We've pondered the marvel of life as we know it on Earth, a symphony of biological complexity shaped by billions of years of evolution. Yet we've also dared to imagine life as we don't know it, forms of existence that defy our earthly understanding. We've contemplated beings that could thrive in environments inhospitable to us, creatures with completely different biological blueprints. The universe is vast and ancient, filled with countless planets and moons. The likelihood of life beyond Earth, of forms of existence we can scarcely imagine, is high. But until we find concrete evidence, these remain educated speculations. As we continue to explore the cosmos, we may one day answer the question that has intrigued us for centuries. Are we alone in the universe?